Okay, so this is model lesson number 2, determining rate law. So I'm going to go through some things on this. So they give you two equations. They give you a slow and a fast step, and now we're going to start putting them together into the overall step. Your states that matter. Okay, that's the only way that you can cross out something. So what I did was I brought down here. I rewrote my equations. I like to have my arrows line up because it makes it a little bit easier for me to see what's on the left side, the right side, so I can knock some stuff out. This is your systems of equations in math. So as you can see, I've blocked this one off. This one I blocked off. Those are going to cancel out. I've got two NOs. I'm going to bring those together, and I get 2 NO gas, Cl2, and 2 NOCl. And that's my answer. That's my overall reaction. So then we're asked to look for the rate determining step. And remember, it's like those freshmen in the hallway who are walking incredibly slow because they're trying to get their updates on Snapchat as they're walking down the hallway and they're slowing everybody down. Your rate to your next class is determined by those slow walking freshmen. Okay, so our rate determining step is our slow step. So for this reaction, it's step 1. So then how do I write my rate law based on my rate determining step? I go back to my equation, and I'm going to have rate equals K, square bracket NO, square bracket Cl2. All right. So then I'm being asked to draw it. So I have 2 steps that are involved, so I had to have 2 humps on my graph. Since my first step is my slow step, that hump has to be higher than the second step. The last thing I have to look at this is ask myself, is my reactance higher than my products, or will my reactance be lower than my products? And that's based on, is it exothermic or endothermic? Since this is exothermic, my reactants have to be higher than the products. So we're going to start up over here. I draw my first hump. Here goes my second hump, and here's my products. Do make sure that you label energy, kg per mole, and then the progress of the reactions over here. Okay, so in class, I'm going to assign you a mechanism, and you're going to partake in this, and you guys are going to come and share together. Okay. But since this is a homework help, I'm going to go ahead, I'm going to go forward with this. So for mechanism 1, this is what I should get when I do it. All right, I blend them together, as you can see my work here, and I get this for my overall. Which step is my rate determining step? Again, I go to my slow. It's going to be step 1. Because this is my slow and determines my rate, then I use this to determine the rate determining step when I write it. Rate equals K, NO2, Cl2. Then I need to draw it. This is an exothermic. There are 2 steps. Make sure you label. It says identify any intermediates or catalysts. Okay. Cl is found on both sides of the equation. It's right here, and it's right here. It is our intermediate. Okay. It's not being used to get this thing started. It's being produced, and then it's being used up. So that's the intermediate, right? All right, mechanism number 2. Here's our 2 equations. Again, you can see my work down here, how I've crossed some stuff out, simplified. I got my overall reaction, okay? Again, which one is the rate determining step? It's my slow one, so it's going to be step 1. Since this is my rate determining step, then my rate equals K O3 Cl2, right? Please note, all right, if you're looking at this and you're like, but wait a minute, that was a reactant and it's being used as a product, that's not an intermediate, that's a catalyst. And a catalyst can be part of the rate law. It's the intermediates that cannot, okay? So a catalyst can be part of the rate law, so that's okay to write that there, right? So I already kind of let the cat out of the bag there. So catalyst is the CL. My intermediate is produce and then used up. That's CLO. Mechanism number 3. Again, you can see my work here, how I got my overall. Which step is my rate determining step? It's my slow step. That determines my rate. So here it is. Rate equals K NO2. Since there are 2 of them, I'm now going to square that. Right? Then my intermediate is NO3. Okay? And then draw your graph. Mechanism 4. Again, you can see my work. My rate determining step is my first step because that's my slow step. My rate law is based upon my rate determining step. So I have rate equals K NO2 and it's squared because there's 2 of them. The intermediate is NO3. Here it is as a product being used up as a reactant. All right, mechanism 5. You got 3 steps involved. So let's go like it's yours. You can see my work down here. Now, when you get down the end here, you're going to have 2, 2, 2, 2. Well, when I write my overall, I'm actually going to reduce that. I'm going to simplify it. So it's O3, NO, NO2, and O2. Okay. My rate determining step, again, I go back to the slow step. So that's going to be step 1. My rate law looks to be K equals NO and O3. All that's good when I look at my work. Okay. My intermediate is NO3 and O. So I have 2 on this one. Mechanism number 6. All right. So we have 3 reactions involved. You can see my work down here on how I got the final equation. Okay. My rate determining step is the slow step. Rate is K CH33CBr. My intermediates, if I look at my work down here, I've got CH3C plus and Br and the CH3COH2. There was actually 3 of them in that one. All right. Let's look at the extension. All right, so we have this one here. This is ozone, and it's being broken down into O and O2. And then O and O3 produces 2O2. So I get my reaction down here. Who is my rate determining step? It happens to be the second step here. So that means when I write my rate law, I have K square bracket O and O3. But if we look at our work here, O is an intermediate. And I said earlier, you can't have an intermediate as your rate step. So what do? We got to do some math. So I'm going to start up by writing my equilibrium expression. Okay? And my equilibrium expression is O, O2 over O3. Okay? And that is going back to my equation on the slow step. Okay? So then I'm going to substitute and move stuff around, and I get O equals KEQ O3 O2. So then I want to go back to my rate law. I want to substitute in the O. I'm going to get rate equals K, KEQ, O3 over O2. Or simplified, K equals O3 squared over O2. One more. Reaction number 7. So again, I found my overall. Slow step is number 2. My rate law is K into O4. But again, a problem because I can't have into O4 because it's an intermediate. So same thing we did on ozone. I'm going to write my expression. Which is the N2O4 over NO2 squared. And if you look at what I have written, that goes back to your step 1 is where that's coming from. Okay? So I write that expression. Then I'm going to move around to get what I don't want there into O4 isolated. Then I'm going to substitute in to my rate law. And then I'm going to get rate equals K into squared. Okay? So that is the homework help for our introduction to the mechanisms and writing out the overall. And wish you the best. Live long and prosper.